Students, welcome to s.mathguru classes. So, we discuss some problems about method of multipliers of first order partial differential equation. Now we consider the remaining problems. We solved some problems. It was given in the last videos. Next, we consider the remaining problems. Solve b minus c by a yzp plus c minus a by b zx equal to a minus b by c xy. We want to solve by using Lagrange multipliers. Now I recall the formula. This is capital P small p capital Q small q equal to R. If we get this type of equation, then auxiliary equation will be dx by capital P, dy by capital Q, dz by capital R. This is our auxiliary equation. This P, Q, R we write in denominator, dx by capital P, dy by capital Q, dz by capital R. So this whole is capital P small p, capital Q small q, and this whole is R. So the auxiliary equations solution, the auxiliary equations are dx by b minus c by a yz, dy by c minus a by b zx, and dz by a minus b by c xy. This is dx by capital P, dy by capital Q, and dz by R. This whole is R. This, just like this. And this a becomes a numerator, a dx b minus c yz, b dy c minus a zx, and c dz by a minus b xy. This is number 1 we consider. So this is our auxiliary equation. Now choosing x, y, z as multipliers, x, y, z as multipliers, each fraction for 1. This equation 1 we taking x, y, z as multipliers, then is fraction for 1, this equal to ax dx plus by dy cz dz by b minus c xyz c minus a xyz a minus b xyz. We get this one. Now if we taking xyz common, ax dx plus by dy plus cz dz, xyz common, then we get b minus c minus a minus b, and ultimately all of this cancel, we get denominator is 0. Ax dx plus by dy cz dz, this denominator will be 0 because b cancel, a cancel, minus c plus c cancel, then this on 0, we get this. By rules, if denominator 0, then we can write in this way, ax dx plus by dy cz dz equal to 0. We get this. Now integrating both sides, integration ax dx, integration by dy, integration cz dz equal to 0, and a is constant, x means x square by 2, b is constant, this is y square by 2, c constant, z square by 2 equal to c1 by 2. We get this. And dividing both side by, multiplying both side by 2, we get this one. So we get first solution, this one. Again, we choosing ax, bx, and cx as multipliers. Again, choosing ax, by, cz as multipliers, each fraction for 1, we get, this is multiplying this one ax, then we get a square x dx plus b square y dy c square z dz by, this is a into b minus c xyz, b into c minus a xyz, c into a minus b xyz. That means we multiplying numerator and denominator by ax, here by, here cz. We get this, and this equal to a square x dx, b square y dy, c square z dz, and here xyz common, then we get ab minus ac, bc minus ab, multiplying ab and ac, here bc minus ab, and this is ca minus bc. We get this one. So ultimately we get a square x dx, b square y dy, c square z dz by, this is 0, because AB cancel, AC cancel, and BC cancel, this is denominator 0. If denominator 0, then we can write a square x dx plus b square y dy c square z dz equal to 0. We get this one. So integrating both sides, therefore a square x dx, b square y dy, c square z dz equal to 0. If we integrate, we get this. So this will be a square x square by 2, b square y square by 2, c square z square by 2, c2 by 2. We get this one, c2 by 2. And multiplying both sides by 2, a square x square, b square y square, c square z square equal to c2. So we get one solution is this, another is this. Therefore, the required solution is f of ax square plus by square plus cz square comma a square x square b square y square c square z square equal to 0. This is the final answer. Because we know if u equal to c1, v equal to c2, then solution will be f of u comma v equal to 0. We cancel c1, c2, we write f of u comma v equal to 0. So this is u equal to c1, this one v equal to c2, answer will be this u and v. This is the final answer. Next we consider another problem. Solve z into x plus y into p plus z into x minus y into q equal to x square plus y square. This problem is given. So this is capital P, this one capital Q, this one R. So the auxiliary equations are solution. The auxiliary equations are dx by z into x plus y, dy by z into x minus y, dz by x square plus y square. Now this one auxiliary equation. Now choosing, now our target to find denominator is 0. Choosing x minus y minus z as multipliers each fractions equal to this is x dx minus y dy minus z dz. We multiplying this one x, this is y, this is z. Here also multiplying by x z x plus y. This is minus y z x minus y minus z x square plus y square. We multiplying numerator by x and this is y, this one z, and here also same. So our main target anyhow to find denominator is 0. X dx minus y dy minus z dz, and this is x square z, and this is xyz, this one xyz plus y square z y square z minus z x square minus y square z. We get this xyz cancel, x square z cancel, and y square z cancel. So what we get? We get denominator 0, x dx minus y dy minus z dz, and denominator we get 0. After cancelling we get 0. If denominator is 0, then we can write therefore x dx minus y dy minus z dz equal to 0. Then we can write in this way by formula. Now if we integrate both sides, we get this one. This is x square by 2 minus y square by 2 minus z square by 2 equal to c1 by 2. Here 2 constant also you consider c1 by 2. This implies x square minus y square minus z square equal to C1, where C1 is an arbitrary constant. So we get this. First is taking x minus y minus z as multipliers, we get this one. Again choosing y x minus z as multipliers, each fraction equal to, that means first one we multiplying by y dx plus x dy minus z dz by this one multiplying by yz x plus y x z x minus y minus z x square plus y square. This one we get. So this equal to y dx x dy z dz. This is xyz y square z x square z xyz zx square y square z. So we get this one. Now y dx plus x dy z dz xyz cancel, y square z, these two are cancel, x square z, these two are cancel, we get denominator 0. If denominator is 0, then we can write therefore y dx plus x dy minus z dz equal to 0, and this can be written as dxy z dz equal to 0. dxy we can write, if we expand we get this, and integrate both sides we get, if we integrate we get this one, and this will be xy minus z square by 2 c2 by 2, multiplying both sides by 2, 2xy z square equal to c2. But you know this formula, if u equal to c1, v equal to c2, two solution, if we have u equal to c1, v equal to c2, then required solution will be uv equal to 0, f of uv equal to 0. So this is our u equal to c1 and v equal to c2. Therefore the required solution is f of x square minus y square minus z square comma 2xy minus z square equal to 0, and this is our final answer. Very easy solution, very interesting also. We consider another mostly problem. X into y square minus z square into p minus y into z square plus s square into q z into x square plus y square. Now this is capital P, this one is small p, this is capital Q, this one is small q, and this one R. So we want to write the auxiliary equation, the auxiliary equations are dx by x into y square minus z square, dy by minus y into z square plus x square, and dz by z into x square plus y square. This is number 1. This is our auxiliary equation. Now our aim to find denominator equal to 0. We choosing some multipliers in such a way that denominator must be equal to 0. Choosing x, y, z as multipliers, each fraction equal to, we multiplying this one by x dx plus y dy plus z dz. We multiplying this one by x, this is y, this one by z, and here also multiplying by x square, y square minus z square. So this is x square, y square minus z square, and multiplying by y square z square plus x square plus z square x square plus y square. Now numerator same, x dx plus y dy plus z dz divided by x square y square x square z square y square z square minus x square y square plus z square x square plus y square z square. X square y square, these two are like terms, this will be cancelled. X square z square, these two is cancelled, and y square z square, these are cancelled. We get denominator is 0. X dx plus y dy plus z dz, denominator is 0. If denominator is 0, then we can write x dx plus y dy plus z dz is equal to 0. By rules, we can write this. Now integrate both sides, we get this, and this will be x square by 2, integration of y dy means y square by 2, this is z square by 2, this one c1 by 2. And multiplying both sides by 2, x square plus y square plus z square equal to c1. This one we get this one. Next again we have to find 0. If this x, this y, this z is cancelled, because other term is square, x, y square, z square, z square, x square, x square, z square. If these three factors are cancelled, then ultimately we get denominator will be 0. Again choosing 1 by x minus 1 by y, 1 by x minus 1 by y minus 1 by z as multipliers. Each fraction equal to, this is 1 by x dx minus 1 by y dy minus 1 by z dz, and this is 1 by x, this one x into y square minus z square, and this is minus 1 by y, and this is minus y into z square plus x square, we get this, and minus 1 by z into z x square plus y square, we get this one, and this will be 1 by x, this is dx, 1 by y dy, 1 by z dz, x cancel, this x cancel, we get y square minus z square, y cancel plus z square plus x square, z cancel, x square minus y square. Then all of this cancel, y square cancel, z square, x square cancel, we get 1 by x dx, 1 by y dy, 1 by z dz by 0. We get this one. Therefore, if we get this is 0, x dx minus y dy minus 1 by z dz equal to 0. Now integrate both sides, dx by x, dy by y, dz by z equal to 0, and this will be log x, log y, log z equal to log C2. Then this is log x, taking minus sign common, log y plus log z equal to log C2. Then logarithm, if it is plus, we can write into yz log C2, and if it is minus, we write division, x by yz equal to log C2. This implies x by yz equal to C2 we get. So this is our second solution, this one first solution. That means if I recall this, u equal to C1, v equal to C2, then f of u comma v equal to 0, this is the required solution. Therefore, the required solution is f of, first one this, x square plus y square plus z square comma x by yz, this equal to 0, and this is our final answer. Very nice solution, very easy, and if you are getting interest, then please share this video to other friends also. These are most important for engineering courses. It may be second semester, third semester or first semester. So these are important. So today I am to stop here. Thank you.